This is my fifth video lesson for Unit 5C. In this lesson, we'll be learning how the intermolecular forces affect solubility of molecules. Let's go to page 20 in the class packet. Motivation. Take a moment to define solubility and solution. This should be review. Learning target. At the end of the lesson, I'll be able to explain how intermolecular forces affect solubility of a molecule. Homework number 5 will be a Junipod based off this lesson. There will also be a quiz Junipod based off PowerPoints 4 and 5. Solubility is the ability to be dissolved. A solution is a homogeneous mixture. It's uniform in composition and it cannot be filtered. There's two parts to a solution. That is the solute and the solvent. So as you can see from this diagram of a solution, the solute is being dissolved in the solvent. It spreads out evenly throughout the solvent. Because the solute spreads out evenly in the solution looks like one substance. So here's an example of making Kool-Aid solution. Here we have a Kool-Aid powder. You dissolve it in water to make your solution. So the solute will be the Kool-Aid powder. That's the substance that gets dissolved. It's the small percentage of the solution. The majority of your solution will be the solvent. That's the substance that does the dissolving. In this case, it is the water. So it's a large percentage of your solution. To help you differentiate between solute and solvent, think of water as the universal solvent. Here are some examples of solutions. Here's a solid solute and a solid solvent. That will be steel. A solid solute and a liquid solvent will be Kool-Aid. A liquid solute and a liquid solvent will be juice or wine. A gas solute or liquid solvent would be soda. A gas solute and a gas solvent would be air. To figure out if a solvent would dissolve a solute, think of like dissolves like. Nonpolar would dissolve other nonpolar. Polar would dissolve polar and ionic. Nonpolar cannot dissolve polar, or vice versa. Remember to treat like dissolves like as a general guideline, not a rule, because there will be exceptions. Since molecules may have different degrees of polarity within the structure of the molecule, they might dissolve in polar and nonpolar solvents. So use like dissolves like to give you a general idea whether something will dissolve, not a general rule. An example of this in nature would be the hydrophobic effect. Is an observed tendency for nonpolar substances to aggregate in an aqueous solution and exclude water molecules. So you should have learned this last year in biology. So you can see from this example, nonpolar substances such as oil will clump together in a polar solvent, such as water. Learning check number 1. Potassium chloride dissolves in pure water is an example of what? Pause the video and resume once completed. Potassium chloride is an ionic compound, so 3 and 4 are wrong. Water is polar because it's asymmetrical, and since it's dissolving potassium chloride, it is the solvent, so the answer is choice 1. Learning check number 2. Hexane and water do not form a solution. Which statement explains this phenomenon? Pause this video and resume once completed. Since they do not form a solution, hexane does not dissolve in water. Therefore, one of them is polar and the other one is nonpolar. Since water is polar, hexane must be nonpolar. So the answer is choice 3. Chromatography, if you recall from Unit 1, is a separation technique based on solubility and the polarity of a solvent and solute in the paper. In these diagrams, you can see that the mixture is being separated into its components. So we will discuss how does this work in terms of polarity. So paper is your polar substance. You're going to put your mixture, which is ink, on the paper. So check of understanding number 1. Which do you expect to travel up the paper the fastest? The polar or nonpolar substance? Ink is a mixture that contains polar and nonpolar components. Since paper is a polar substance, you expect the polar components of ink to stick to the paper, and the nonpolar components of ink will travel up the paper. The reason why polar components of ink will stick to the paper because paper is a polar substance. Polar substances form stronger interactions with other polar substances than nonpolar substances. That's why nonpolar substances will not stick to the paper as much and will travel up the paper. What type of solvent do you have to add to move the polar molecules? Since the polar molecules are stuck to the paper, you want to use a polar solvent to move the polar molecules because the polar molecules will form interactions or intermolecular forces with the polar solvent. Check of understanding number 3. Indicate in the diagram which components of the ink are polar and nonpolar. The nonpolar will be on top and the polar will be on the bottom. Keep in mind, because our medium, which is paper, is polar, the nonpolar components of the mixture will travel the furthest. If we use a nonpolar medium, then the polar substances will travel up the farthest. Motivation number 2. Sugar and salt have different types of bonds, so sugar is covalent, salt is ionic, yet they both dissolve in water. Why is that? Let's start with dissolving ionic compounds in water. Here we have salt, NaCl. NaCl exists as a crystal lattice. When it dissolves in water, water will form intramolecular forces with the salt. Water will interact with the ionic crystal through molecule-ion interactions. For water to interact with sodium, the oxygen of the water molecule will face it because the oxygen is partially negative, and then will interact with the sodium ion through opposites attract. So they will pull the sodium ion from the crystal lattice. For the chlorine, it will be the hydrogen atoms interacting because hydrogen is partially positive. Through these intramolecular forces, they're going to pull the chloride ion from the salt crystal. So the water molecule will interact with each ion by surrounding it and pulling them from the salt crystal. At this point, the salt is completely dissolved. You no longer see the crystal lattice structure. The water molecules completely surround each of the ions, and the ions is evenly dispersed in the solvent. Water forms molecule-ion interaction with the ion, thus breaking up the crystal lattice. Here's a GIF of what's happening. You can see that the water molecules are slowly dissolving the ionic compound by interacting with each of the ions. Another way to think about it is that salt and water are both considered polar. Remember, like dissolves like. Keep in mind, not all ionic compounds dissolve in water at STP. Why is that? So there's two interactions here. One is the ionic bond, and the other one is the molecule-ion effect. Remember, you first have to break the ionic bond before you form the molecule-ion interaction. Breaking XOR releases forms. So it costs energy to break the ionic bond, but energy is released when it forms the molecule-ion interaction. So in order for your ionic compound to dissolve in water, the energy released from the molecule-ion interaction must be greater than the energy it takes to break the ionic bond. In order for the salt to dissolve in water, the energy released by the intramolecular forces interaction, that's the hydration energy, must be greater than the energy required to break the ionic bond, that's the lattice energy. If you plan to take a BChem, you'll be doing calculations involving the hydration energy and the lattice energy. Now we're going to talk about how does a covalent compound such as sugar dissolve in water. How does one sugar molecule interact with another? So here are two sugar molecules. How would they interact? They will interact through hydrogen bonding. Notice they have O and H. So how will water interact with sugar? It will also interact with sugar with hydrogen bonding. So since water and sugar are both polar, like dissolves like, sugar will be dissolved in water. So basically, water will hydrogen bond with sugar by surrounding it and breaking up the sugar's intramolecular force with other sugar molecules. So you can see here's your sugar crystal. The water molecules are surrounding it and forming hydrogen bonds with it. Covalent molecules like sugar do not break apart into its components like ionic compounds. If you recall, when ionic compounds dissolve in water, the crystal lattice disperses into its ions. But if you look at sugar, when sugar dissolves, sugar does not break apart into its atoms. In summary, when salt dissolves, they dissociate into ions in water, forming molecule-ions interaction. When sugar dissolves, it forms hydrogen bonds with water. For this practice, I want you to identify if the following solutes will best dissolve in a polar solvent like water, or a non-polar solvent like hexane, or both. Pause this video and resume once you complete it. Here are the answers. So this concludes the video lesson for today. Remember to do the junior part homework and quiz.